Another question asked us to do the same thing we did here, but using the points 2, 7, and x, y. Well, fairly straightforward that to get the run, we subtract this coordinate from this coordinate, the x coordinate of this point from the x coordinate of this point. It's going to give us x minus 2. And same thing with the y coordinates. We get y minus 7 for this side of the triangle, giving us a hypotenuse that's equal to the equal in length to the square root of the sum of the squares of this and this. So it's the square root of the quantity x minus 2 squared plus y minus 7 quantity squared. Very straightforward. We could also write the expression for the slope between these 2 points. And I'm not sure I did that because, of course, the text didn't ask for it, but let me add that. What's the slope from here to here? Well, slope is rise over run, which in this case is y2 minus y1 over x2 minus x1. Another comment, the statement is also given that the distance between 2, 7 and xy is 5. Okay, and how do we then, of course the instruction was to translate the statement into a mathematical expression. In this case, the expression would be an equation because it said something is something else, which means that this equals this. Okay, well, something equals 5 then. So we're going to have an equals 5. What is it? The distance between 2, 7 and xy, which we just found, and which, if we were just given this statement, we would be expected to find by sketching, excuse me, not by mindlessly using a formula. And we get the expression for the distance being this square root, which would then be equal to 5. Now, the question is given, if I plotted all the points at distance 5 from here, what would I have? And somebody said, well, you'd have a circle. Exactly. We'd have a circle whose radius is 5, since the points are all at distance 5 from the center, and centered at this point. Okay, so right here we have the equation of circle of radius 5 with center 2, 7. You're also asked to put a point right in the middle of this segment and then figure out what its coordinates are. Well, people did this essentially the first answer, and it's a good answer, said, okay, well, we go over halfway here, we go up halfway there, so we're going to go over 4 and we're going to go up 3. Okay, and that's good. If we start at 3, 5 and go over 4 and up 3, well, we start at x coordinate 3 and we increase that by 4. And of course, we can see that here. We're starting at 3 and moving 4 units. So that's going to get us to x coordinate 7. And we start at 5 and we go up by 3 units. Where are we going to end up? We're going to end up with y coordinate 8. Okay, so starting at 3, moving over 4, we get to 7. In the vertical direction, starting at 5, going up 3, we get 8. So that's going to be the coordinates of this point. And that's a very good way to do it. Now, an even more general way and an even simpler bit of reasoning. Okay, let's project this point down to the x-axis. How does the location of this point compare to the locations of these 2 points? How does this point compare in its location to these 2? Well, people very promptly said, well, it's halfway between. And then I said, well, okay, well, how do you get the coordinate of a point that's halfway between? The coordinate of a point on the x-axis is halfway between 2 other points. And of course, this has been done in earlier chapters, but it's very obvious that you just average these 2. Okay, so the x-coordinate of the middle is halfway between, and halfway between is the average. In this case, 3 plus 11 divided by 2 gives us 7. So we determine by averaging these 2 coordinates, the 3 and the 11, that the x-coordinate is going to be 7. And we could average the y-coordinates for the same reason. We could project over to the y-axis and see how that works, and it's worth doing. But 5 and 11, how do we average two numbers? We add them and divide by 2. So we add these and divide by 2. We get 16 divided by 2 gives us 8. So we get the y-coordinate. More generally then, if our points are x1, y1, and x2, y2, well, halfway between x1 and x2 is what? Average them. Add them and divide by 2. x1 plus x2 divided by 2. That's going to give us our x-coordinate. And we do the same thing with the y-coordinates. And another formula that would be ridiculous to memorize if you simply understand that to get halfway from one point to another, from one coordinate to another, you're going to have to average them. Okay. Now, one last thing. We put a point xy out here somewhere on this picture. And then we express the slope between 11, 11 and xy. Slope of this segment here. So we're just looking at this point and this point, asking what's the slope of the segment that joins these 2 points. Slope is going to be rise divided by run. The rise is y minus 11. The run is x minus 11. So the slope is what? The slope is rise, y minus 11, divided by run, x minus 11. Now, there's a very important idea here in this picture. I'm going to say, well, it doesn't look like xy is on this line. Why not? Because it looks like you have a different slope here than you have here. If you had the same slope here, then xy would be on the same line as 3, 5, and 11, 11. And, of course, 7, 8 is also on that line. Okay? So, if we set the slope, the expression we get for the slope of this triangle, equal to the expression we get for the slope of this triangle, we're going to have an expression that embodies the statement that this slope is equal to this slope, and therefore that this point is on this line. So we can say then that xy, and you got to kind of follow the blue writing because I just had 2 blank spaces on the board, but I wanted to include all this. Your statement is then that xy, the point xy lies on the line if and only if the slopes are equal. Now the slopes, I mean this slope and the slope here. Remember, the slope of this triangle was 3/4, and the slope of this triangle is y minus 11 over x minus 11. So the statement says that xy is on the line if and only if this is equal to this. Now, we haven't proven the if and only if, but we've proven the if. Okay? The only if takes a little more proof, but at the level of college algebra course, we're not going to worry about the intricacies of what we mean by if and only if. It simply means that if x and y satisfy this, then this point is on the line, and also if this point is on the line, x and y have to satisfy this. We've proven the latter. We haven't really proven the former, but you can accept it. Now, what's this? This is the equation of the straight line through the points 3, 5, and 11, 11, as well as 7, 8. I'm going to write down just a little more. I'm going to do that off screen, then we'll talk about it. You can and should easily verify that if we solve this for y, we get y equals 3/4 x plus 11/4. And this equation is called the slope-intercept form of the equation of a straight line. This form can be derived simply by setting this slope equal to this slope. Drawing this picture, the 2 points and a point xy, getting the slope of this triangle and the slope of this triangle and setting them equal. Okay? And then the slope of the line is the coefficient of x, 3/4, and of course we know the slope is 3/4, plus 11/4, and 11/4 would be the y-intercept. Now, we didn't draw the y-axis. We're not even going to estimate the y-intercept. That's the slope-intercept form, in any case, of the equation of a straight line. And that form can be expressed by completing this picture by putting a point xy up here and doing the slope of the resulting triangle and setting that slope equal to the slope of this triangle. And I guess I'm going to draw that in. Okay, things are getting really cluttered, but what I've drawn is I've drawn a point here that I've labeled xy, and I've drawn a right triangle with legs parallel to the x and the y axes. And I haven't written in the rise, but the rise is going to be y minus y2, and the run is going to be x minus x2. So the slope is y minus y2 over x minus x2. If we set this equal to the slope y2 minus y1 over x2 minus x1, then we're going to have the equation of a straight line in terms of the coordinates x1, y1, and x2, y2. Another example of a formula whose meaning is important and whose meaning can actually be gleaned from pictures. A formula which you would be unlikely to remember unless you'd used it recently.